And is the distance x? Or is it this one? So what would the equation for this be? So here's your beam, right? And this is the support, so it'd keep going this way. And you've got x over here. And then you want to find out this distance in terms of x. So if x is 1, what would d be?
X was 1.
Yeah.
D would be 1.5.
So how did you find that?
I did. So X is 1. I did. Supports is 3 meters apart. Beam and it has to equal to 5.5. So X was 1, and we got a minus. We got to add up to 5.5.
Right.
Anyways.
So you'd have
So
5.5 minus 3 minus your x. So this would be d equals 2.5 minus x. So you put that in here. So that takes care of, this one is on the support, so you don't add it. You added this one and you've added that one. What about force 1?
we would add it. We add it on to be plus 42. Oh, let's see. It's positive because it's going counterclockwise.
Well, it would cause it to spin this way, so that'd be negative.
Oh, like when it rotates?
Yeah, so we're rotating right about this point right here.
Right, okay.
So force 1 would be spinning it that way.
So minus 42 times 9.8 times 2.75.
So don't worry about this one, just think about this as if it's this. You just have to look at each force independently. And this is 3 meters, right?
Maybe F1 times 9.8.
Well, no, not times 9.8 here, because it's not a weight, right?
Oh,
The only reason we were multiplying these was to get a force.
okay.
So it'll just be
Times
F3.
3.
So times 3 times the sine of 90, but we'll leave that off. All that equals 0. So what's this going to be?
What's the answer?
Well, you've got an equation now that looks like this, right? 42 times 9.8 times and sine of 90 is 1, so times 2.25 minus 23 times 9.8 times 2.5 minus x minus 3f1 equals 0. So we have one equation, but how many unknowns do we have in this equation?
2.
Yeah, so we don't know x. We don't know f1. X is what we're solving for, so we want to try to get rid of f1 somehow. So if you go back and think about this, what's going to happen right at the moment he goes too far?
Rotates.
Yeah, it'll lift.
Lift up.
And what will happen at this point?
That force won't do anything.
Yeah, so it won't be touching that force anymore, or that support anymore. So it'll actually become 0. So the moment right before he starts to tip will be right when that support starts not doing anything. It'll be touching, but it won't be holding anything up. And then if he walks out further, it'll be a net torque and it'll twist it. So there will be a point, right, where he can stand here and you would be able to pull that support out because he'd just be balanced. And then if he stepped one step further, it would start to tip. But there is one point where he can stand and you'd be able to pull out support 1 because it wasn't doing anything. So that's how we get rid of this, is we recognize that it'll be twisting, it'll turn. So at the moment when it's all balanced, F1 isn't required. So we can make that 0. And then we'll be able to solve it.
Okay.
So we've got 42 times 9.8 is 0.25 minus 23 times 9.8, 2.5 plus 23 times 9.8 times x.
Goes negative to 235.2, but you have to bring that over to the other side.
So
Make
this
positive.
is that what you're saying?
Yeah. Oh,
Yeah, so you bring it over and then you divide by that.
okay. That'd be negative 2.04. Is that right?
Should be positive. So you should have 23 times 9.8. All right, let's see. So you move this over, so you have 235.2, and you divide by this.
Oh, wait. Something off. Okay. So it's positive 2.84. I didn't take the negative off.
I think it should be closer to 1, just because this will end up being about 230. So 235.2.
I think I accidentally, on the top one, I plus the 23 times 9.8, so I went back and
Oh, okay. So
so it came out to be negative 460.6. And then I divided it by 2, 23 times 9.8.
oh, okay, there we go.
Sorry, that's my.
Gotcha. Okay, so that's right. So So it's really 460.6 or something. Okay. And does that make sense? So you can only, the furthest you can go is when this is about 2.04 meters. So that would still be on this side of the support, but it wouldn't be like clear out. So if you'd gotten a negative number, that would be saying that he could walk clear out here. You know,
Yeah.
so that would make sense. If you'd gotten something greater than 2.5, that would be saying the only way to be safe is to stand between these two. That's not true either. So, all right.
Pulleys. 2 blocks in a figure are connected by a massless rope that passes over a pulley. The pulley is 16 centimeters in diameter and has a mass of 22.2 kilograms. As the pulley turns, friction at the axle exerts a torque of magnitude 0.45 newtons times meters.
Okay.
If the blocks are released from rest, how long does it take the 4.1 kilogram block to reach the floor? The pulley is 16 centimeters in diameter and has a mass of 2.2 kilograms.
What's its
Friction is.
diameter? Sorry.
The diameter is 16 centimeters.
So that'd be 0.08 meters in radius.
Oh, and the friction is 0.45.
So friction exerts a torque, right?
Yeah.
0.45 newton meters.
The axle.
All right.
That's asking how long it takes for the 4.1 kilogram box to reach the bottom. It's the floor.
So you have stuff about forces and torque, and you need to find out time. So that's like a kinematics thing. So that means we're going to be using this kind of a relationship, solving for acceleration. Okay.
Force and mass.
Well, we need to solve for the forces. So free body diagrams.
Okay, so
Let's call this A, B, and P.
okay, so the 4 kilogram is 4 times, well, has gravity at 9.8, 4 times 9.8.
Okay.
And that has the tension.
Yeah.
And then box B has gravity at 2 times 9.8, and that has a tension.
Okay.
P
This was a little different. I have to draw it as like the actual circle.
circle. That's like a circular. Well,
What's pulling on it on either side?
rope.
So you've got a rope on this side. What's the tension in that?
4 times 9.8.
Not exactly. That would mean that these two are equal, right? The A has to accelerate, so they're not going to be equal. But this one will be equal to T1.
Okay, equal to T2.
Okay.